Some of you may be aware that the project from the onset has taken the stance that it must include all of the stakeholders. So we have on board government, who is the lead organization in this project, and the main team is from ZARI, which is the Zambia Agricultural Research Institute. And we're also a stakeholder in agricultural development. We have a small NGO called Grassroots Trust. Been working in Zambia, like Sandra said, personally for 20 years. Farming, but Grassroots Trust is about seven years old, and we've been working in natural resource management with communities and partner organizations. So I think always we like to give a bit of context behind why we approach things in a certain way, and just to give some of our listeners a bit of the context of Zambia for those who are not familiar with it. One of the main issues for us, or the elephant in the room, is that we have rapid population increase. So according to the statisticians, and it's not very difficult to do the mathematics on a small piece of paper, we're currently having average birth rate of 5 children per family. So currently we're 18 million people, 60% of those are under 16 years old. So it doesn't take a genius to work out that we'll be at around 50 million by the year 2050. And this is going to put a huge pressure on our natural resource base. And it's not going to stop at 50 million, of course. It will go beyond 50 million as time goes on. So we really have to think about the sustainability of our food production systems, and also the way farmers are using the land is going to affect the water cycle, nutrient cycle, and these are big issues. So it's not just agriculture we're talking about, we're really talking about ecosystem management. So so the other context which is important to be aware of in Zambia is most of the resources are actually managed by communities, not individuals. And this has a big bearing on the approach you must take when tackling improved natural resource management. If you're an individual, you have rights to do whatever you want on your land as long as it's within the laws of the country. Here, most of the resources are communally owned, meaning the forests, the fisheries, and to some extent even the fields farmers use during the dry season, the off season, they're actually open to use by everybody. So this is distinctly different from places like Europe where you have private ownership of your natural resources. One of the things that happened because of the rapid population increase in Zambia is that in the past, farmers relied heavily on long-term fallows. This was the general soil maintenance practice and was easily achieved and sustainable within the context of small populations with a large land resource. Currently, that's becoming less and less, as has happened everywhere else in the world. So you have less capacity for the farmers, less opportunity for the farmers to use this long fallow system, which, like I said, did a very good job in the past of maintaining soil fertility, and soil function is not just the fertility. So replacing organic matter, which meant all the functions of keeping the soil loose and friable, allowing rainfall infiltration, water holding capacity, all the benefits of organic matter in the soil basically were achieved for free or very, very cheaply, just the labor to carry out the long-term fallow, basically the clearing of the land. So farmers don't have access to that increasingly, and as population increases, they'll have less access to this. So fertilizer has been promoted for many years in Zambia, and despite these efforts, only 26%, according to IAPRI data, which was the result of a rural agricultural livelihood study which was done in 2012 and 2015, the most comprehensive rural livelihood study ever carried out in Zambia. It seems to indicate that 26% of the farmers only using fertilizer, and the majority of this fertilizer is going towards maize production, which is our staple crop in Zambia. And the other point to be clear about or to understand in Zambia is that motorized mechanization, as distinct from animal draft power mechanization, the use is below 2%, according to the IAPI study. So this is a little bit of background into the Zambian context. So following on from that, we have prevalent crop systems in Zambia. As I mentioned just now, maize is kind of dominant throughout the country, even in agroecological regions where it's not particularly suited to, like the valley areas, which receive very low rainfall, very high temperatures. It's still tending towards maize-dominant production systems. And some of the issues surrounding maize production are that, like I said, as access to long fallows has reduced, the dependency on fertilizer has increased, and it's been something which has really been pushed by government and other people involved in agricultural development, such as the donors, to increase fertilizer use to achieve higher maize production. But still, we have very low average yields and very low fertilizer use, and we'll talk about some of the reasons for that as we go on. So, generally speaking, for maize, one of the main reasons maize is the dominant crop is that it's a political crop, in that the government have to ensure that there's food security in the country. So, ever since independence, there's been what's known as the Food Reserve Agency, which is responsible for making sure there's enough maize in the country. And part of the Food Reserve Agency strategy is to buy maize from buying centres in rural areas around the country. And in the past, it's been subsidised. So this is in fact, it's still subsidised today, although much more limited than it was. But because of these factors, maize is, grown all over the country and is a dominant crop. So historically, the markets have been stable and continue to be relatively stable, although there are quite severe price fluctuations depending on annual production availability of maize. In contrast, we have unstable markets for other staple crops such as cassava, beans, groundnuts, millet, sorghum, cowpea, sweet potato. These are mainly sold through local markets. There's no centralized system for purchase, or there's no subsidy for these crops. So they've remained kind of, how could you put it, less dominant than maize, can I say. Although cassava is produced, in terms of starch production, cassava is almost competing with maize because it's produced mainly in the northern areas of Zambia where you don't have much livestock during the dry season, so there's no competition with the crop, so that enables farmers to grow more cassava, as well as the fact that in the northern province of Zambia, a very high rainfall and acid soil, so cassava tends to thrive in those conditions. So also we have underdeveloped markets for some of the crops we're using in the Save and Grow project, which are actually dual-purpose or multi-purpose crops that are going to allow us to recuperate soils, or at least return organic matter and optimize biological nitrogen fixation. The other issue farmers face is, there has been a lot of question about why farmers are not using as much fertilizer as other regions in the world that were kind of where Africa is now, maybe 10, 15 years ago. And part of the reason is, at least for Zambia, we're a landlocked country, so transport of fertilizer into Zambia is costly. We don't have natural gas, so we can't produce our own nitrogen fertilizer, so most of it's imported from as far away as Norway. Also, access to markets outside international markets for our produce is a bit lower, but which limits our limits our marketing capability in terms of competing with other countries for our produce, such as maize and cassava. It just simply doesn't make sense because of the transport cost of getting the stuff outside Zambia. Although we do have regional markets, and they're picking up because we've had instability in some of our neighbours in recent years. Mozambique, Angola, Democratic Republic of Congo are now stabilizing and becoming more our customers as time goes on. So one of the issues with smallholder access to fertilizer or use of fertilizer, the reason it's so low, another reason is that it's very difficult for farmers to make enough money, to save enough money to reinvest the following year. So that's a big issue, and if I can kind of elaborate a little bit on that, these are smallholder farmers, 1 or 2 hectares each. They've got other priorities, sending children to school, they have big families in the rural areas. The average for Zambia is 5 children per household. In the rural areas it's more like 6 or 7. All of these children need to be educated, clothed, fed, taken to the clinic when there's a problem. So from 1 or 2 or 3 hectares, it's very difficult to save enough money from your production to reinvest. So that's where you find the farmers are really reliant on the fertilizer subsidy which comes from the government every year. So they'll spend all the money and then wait for the subsidy to come. And this is fraught with issues because if it comes late and they don't plant on time, then they lose their production potential. So there are issues surrounding that too. So the other thing is because the farmers are so poor, I don't know if that's correct, am I allowed to use that word in Rome? Not poor, resource constrained, sorry. Because the farmers are so resource constrained, it's very difficult for them to repay loans as well. So you have a situation where loans are the interest rate for smallholder farmers in Zambia is around 35%. It's very, very difficult to get that kind of return from a crop, especially where you're having crop failures. In Zambia, the last 3 years, 2 of the last 3 years have been drought years. So trying to get a 35% return on investment for buying fertilizer is very tricky. So there's all sorts of issues around Zambian context. So, like I said earlier, the project has taken the stance that it must involve the stakeholders. This must be driven by government and other actors in the development arena, agricultural development arena. And from the onset, there's been a very inclusive process. Universities, Ministry of Agriculture, Research Department, Agriculture Research Department, Livestock Department, all the INGOs, local NGOs were consulted during the initial year of planning for the project. And what was decided is we really needed a farming systems understanding, evaluation of what was going on in Zambia in order to know really where we should focus our activity and work moving forward. So through the farming systems approach, we've come up with typologies, farm typologies, and from these typologies we've selected 2 areas under the project for the first year, which were Kasama, which is in the northern province of Zambia, typically high rainfall area, typically acid soils, typically major cassava growing area for staple carbohydrate and beans, typically low use of fertilizer, much below the national average, for example. And this is mainly because farmers traditionally haven't used any fertilizer on cassava, and only recently maize has become a dominant crop in the north of Zambia. It was pretty much cassava based, but that's changed. So it's around 50-50 at the moment between cassava and maize. And the prevalent fertility systems in the north of Zambia have traditionally been a long-term fallow with a modified slash and burn system. But similar to other parts of the country with their long-term fallows, this is becoming less and less available to farmers, or less and less applicable in the face of increasing populations with a fixed land base. So in this area, the farm typology we were really looking at is the organic dominant system. So the way we came up with the farm typologies was to look at nitrogen, as nitrogen is a major limiting resource or limiting factor in crop production, especially if we're looking at maize-based systems. And the project really had a look at modeling around, looking at carbon, nitrogen dynamics and flow through the system. And by looking at these nitrogen dynamics, we came up with the farm typologies. So there was high fertilizer dependence, which are some of the systems in central and southern Zambia, which are basically monoculture maize systems, which have a high requirement for nitrogen. And farmers in those areas, like in Mumbwa, which is in agroecological region 2, between 800 and 1,000 millimeters rainfall, reasonably fertile soils, non-acidic soils, and close to markets and close to fertilizer distribution points. So they were a different scenario. They're inorganic fertilizer dominant systems. So they're amongst the farmers who are using the most fertilizer in the country. So we chose two farm typologies to focus on. One which is organic dependent, meaning much less fertilizer, still a bit of fertilizer use, but much less fertilizer. In the balance, I think they've got a negative nitrogen balance in general, so their soils are continually being mined for nitrogen because there's not enough nitrogen going back into the system from harvest takeoff, whereas the inorganic system is more or less balanced, or slightly tending towards nitrogen, putting more nitrogen on, a positive nitrogen balance in the soils. Looking at these two farm typologies, how do we then look at these and try to improve their production systems through the use of the save and grow approach? Okay, next slide. So, so we come to the approaches for save and grow for the Zambian farming systems, and reducing external input costs. And we have there in brackets risk, because again we come back to this scenario where we have a situation where you may not get a crop at all in 2 out of 5 years or 3 out of 5 years. So weather's becoming more erratic, so it's more of a risk to invest in external inputs. So reducing input costs and risk for farmers, and looking at improving the natural resource base at the same time as increasing production on a sustainable basis. It sounds like a bit of a mouthful, but basically the way we set to achieve this is by improving biological nitrogen fixation and the way nitrogen moves through the system, also using multi-purpose crops, not just for nitrogen fixation or soil improvement. They must benefit farmers in other ways. I think a lot of the research in the developing world, especially in Africa, farmers need to see immediate benefit as well as other benefits. So it have to be a food or a fodder crop or a livestock feed or something extra, not just soil improvement benefit. And all of the work we've done with our partners in the past suggests that this is the same. There's very little to suggest that farmers will adopt on any kind of scale just soil improving crops. So we're looking at that, and also improving nutrient use efficiency of fertilizer or manure that's applied, and we have various strategies which I'll cover just now. Okay. So Kasama, I've given you a bit of background in Kasama, just to reiterate that it's a high rainfall area, acid soils, traditionally maize, cassava growing area based on long fallows and modified slash and burn systems. Ecological region 3 of Zambia. So we have rainfall between 1,000 and 1,300 millimeters per year, basically cooler temperatures in the other agroecological regions, which allows farmers to grow beans as a major part of their production system as well. So staple crops, groundnuts, beans, cassava, maize, and millet also forms a big part of the agricultural production system, especially in the slash and burn system. So the agronomic approaches for the system in Kasama were basically looking at the two distinct farming systems in Kasama. So the one farming system is a hand hoe based ridge tillage system, where farmers are planting on the ridge to facilitate drainage. So overall tillage, so quite intense tillage system. And that was traditionally combined with a technology called fundukila, which is basically burying organic matter in a mound to have an in situ composting situation, a bit like a green manure, and then planting on top of those mounds. Although as time's gone by, fertilizer has replaced that traditional system, although in some places they use it in combination with each other. And that was basically a soil maize cropping system. So not really intercropping, soil maize. So the interventions we brought in Kasama basically focused around, like I said, incorporating high biomass, because the other thing is not just nitrogen fixation we're looking at increasing having a positive balance on carbon, because we know that carbon gets lost through mineralization. Whether you till or you don't till, you still lose carbon. Obviously, if you till, you lose more carbon. So can we have a system that produces more carbon than is lost? And this is really the holy grail. At the same time, we want to produce nitrogen from these extra crops which we're pushing in there to get increase in biomass. At the same time, we need food or fodder or something extra from these crops. So incorporating these crops into the system, into the traditional system, by reducing tillage, as Sandra gave us the introduction, that we want to reduce tillage because this leads to erosion problems and excessive carbon loss in the system. Reduce the tillage, increase the biomass, increase the nitrogen fixation, increase the overall food production in the field by modifying slightly what farmers are already doing. We also looked at best practice in terms of fertilizer use, using the integrated soil fertility management guidelines. So we're looking at reduced and split dosing to really try and get the cost and risk for the production down, at the same time as maintaining or increasing crop production. Another aspect we looked at was the use of some of the low nitrogen, drought tolerant maize varieties which have been produced by CIMIT through CIMIT breeding programs, also by some of the private companies. These have been very successful. And low nitrogen, I don't know if you are familiar with the low nitrogen drought tolerant maize breeding program, but it's really looking at varieties for smallholders who don't have access to enough fertilizer. So low nitrogen, breeding for low nitrogen, performance under low nitrogen conditions, and also performance under drought stress, drought tolerance, drought stress. So this has been a very successful program in Zambia, and we tried to integrate this into the program. And then the other aspect was use of biological insect control, mainly through the use of Bacillus thuringiensis, BT, and that was specifically for pigeon pea pests. Pigeon pea is quite susceptible to cotton bollworm. What's it called? Anyway, I'll remember it in a second. And then the other thing was to facilitate the planting or the efficiency, increase efficiency and reduction of labor for the farmers. We introduced the jab planter, I'm sure everyone's familiar with that from South America, developed in South America, which allows you to direct seed and apply fertilizer at the same time. This was used for maize in the maize system, and the other thing we were working on was use of the two-wheel tractor and a single row direct seeder as a means to reduce labor and improve the efficiency of the system. So that was for the maize-based system, soil maize-based system. These are the improvements under the Safe and Grow approach. Helicoverpa amigra, I think it is. Helicoverpa amigra, the cotton bollworm, which is a major pest of the pigeon pea. So the other dominant system, like I mentioned, was what they call chitemene, which is a modified long-term fallow system, where the farmers traditionally cut a wide area and then heap all of the wood and leaves on a small area of the field. Depending on the size of the forest, it can be anywhere between 50% and 10% of the area which is cut is heaped on one place and left there to dry and then burnt. So it's not a traditional slash and burn system in that where you cut everything, leave it where it is and burn it. This is a much more intensive burning of the soil, and it's quite well documented. This corrects acidity very well and liberates nitrogen. But obviously, as time goes on, populations increase, access to land resource reduces. This is less and less applicable to farmers. So in the past it was okay because the trees grow back, although it's been discouraged in Zambia for 65 years. So farmers use it still today, even though it's against the law, meaning that there's a lot of value in the system. So what we're trying to do is come up with a system which reinstates soil fertility, using that system as a starter to reduce the acidity, liberate nutrients, to grow a crop, and then introduce again our high biomass producing crops, multi-purpose crops in there. So those are the two approaches in Kasama. Can I have the next slide, please? Okay, so yeah. So for the chitemene system, you can see a slide here of traditional chitemene, where farmers cut the trees, heap it, burn it, and then broadcast millet, or they plant cassava first, then broadcast millet in an intercropping system, and in the second year the cassava takes off and they intercrop groundnuts in the cassava, and the third year they begin harvesting cassava. So you can see pictures here of the millet during the growing season. One of the other advantages of the chitemene system is that you don't have to weed. Once you burn the wood, all the weed seeds die. But this is something we're trying to discourage, and if you look at the bottom picture there, you can see pigeon pea doing quite well in an alley cropping configuration between the millet, and we also have the cassava established in there too. So, the other thing I haven't mentioned, I've forgotten, was the addition of Gliricidia sepia. Although I've said farmers won't have a crop which is solely for soil fertility maintenance, Gliricidia sepia is exactly that, but it's at a low population density towards compared to other alley cropping configurations. So we figure that will be much less labor and still achieve part of what we want to achieve, as long as it's done together with the other multi-purpose legume crops. So, yeah, I think we can go on to the next slide. So now we come to Mumbwa, and like I said, this is an agroecological region 2A, where we have reasonable rainfall. It's a high production area, high fertilizer use compared to other regions of Zambia. And our main strategy here was to look at ways, again, similar to Kasama, but again, improve soil quality, soil fertility, soil carbon over time through the use of multi-purpose leguminous crops which are integrated with the other crops. Oh, I think I forgot to mention that traditionally in Zambia, green manure crops have been used in rotation. But as fertilizer came along and became readily available at a very low price in the beginning, farmers tended to move away from the green manure because you need to take land out of production. You still have the cost of seed, cost of establishment for green manure. So our approach for the green manure isn't as in a traditional sense in a rotation, but intercropping together with the traditional crops, and just making slight changes to the traditional cropping systems to integrate the legumes. So in Mumbwa we were basically looking at integrating velvet bean, which is well known to be one of the best crops for soil improvement. Unfortunately can't be eaten, so the only other benefit, benefits that the velvet bean can give are livestock fodder or livestock feed from the seed. So Mumbwa is an area where we're working in agro-pastoral based cropping systems. So in the dry season, we have a lot of cattle, goats, pigs moving through the fields, and velvet bean offers an opportunity for improved livestock productivity. Although there are issues around this because, like I said earlier, these are communal lands. So guaranteeing that your animals are going to eat the velvet bean has issues surrounding it, which we can talk about going on. So yeah, Mumbwa, agro-pastoral based, maize dominant systems, although they do grow some sunflower, increasingly soybeans as the market for soybeans is stabilizing, and a little bit of groundnut is the traditional crops. Small amount of sunflower too. So because it's an agro-pastoral based system, we looked at how can we use the cattle manure, goat manure, chicken manure, livestock manure that's available to farmers in a way that it improves soil fertility and reduces fertilizer cost, and also reduces their risk against drought. Something we saw very strongly this year. All the farmers who used manure on their fields really did so much better than the farmers who didn't, because there was a very long dry spell. This is a drought year in Mumbwa. In contrast to Kasama, there was above average rainfall this year, but in Mumbwa there was a drought year, at least some parts of Mumbwa. So using the cattle manure as efficiently as possible, placing it near the root, so the root has early access rather than broadcasting it, which is the traditional system, and at low rates in combination with low rates of fertilizer. That was the one strategy. Again, using the drought-tolerant, low nitrogen maize varieties. Again, biological control with BT specifically for the pest for pigeon pea. Because it's an agro-pastoral based system, most of the farmers are using animal draft power. So we were using a minimum tillage tool called the Magoi Ripper, which has been developed and refined in Zambia over the last 15 years or so. Allows farmers to just create a furrow for planting into, which has been accepted quite widely by farmers, especially in this area. It's a conservation agriculture tool. And the other thing we thought to reduce the labour even further was to introduce a two-wheel tractor with a two-row direct seeder from Brazil. And yeah, so we've done intercropping with velvet bean, pigeon pea, cowpea, in Kasama, common bean, together with Leucidia sepium. So just to see the performance of these different crops in the different environments, and we've tried to get the right varieties according to the current information base we have in Zambia. So yeah, you can see the treatments there. So the farmers had the control as the moldboard plough, which is a standard practice. And in this area of Zambia, they use the moldboard plough to control early weeds, and they also use it to seed. So they'll actually bury the seed with the moldboard plough, and this is the traditional practice, although this leaves soils open to both wind and water erosion, especially on slopes. So that was our control, and that was a full rate of fertilizer applied to that, and then half rate of fertilizer applied to all of the save and grow improved practice treatments. Like I said, along with a bit of manure applied in the rip line close to the seed at low rates, around 4 tons per hectare, which is very different to the conventional rates, around 10, 20, even 30 tons per hectare. This is the standard application of manure. So we have quite a bit of research from Zimbabwe saying that you can really improve your efficiency of use of the manure by applying it either on station or in the planting row. So getting as close to the roots as possible really makes a big difference. So we've incorporated that into our treatments in Mumba. And you can see, despite the drought in Mumba, we had quite high yields, although the data set for the yield and the analysis for the yield hasn't been done completely, so I don't want to share it with you in this, but it looks like it's around between 4 and 5 tons per hectare, which is more than double the national average for maize, and about 35% more than the average for Mumba, which is a high fertilizer intensity use area. So even in the first year, before these legumes have really started to impact the system, it's showing positive results from reduced rates of fertilizer and precision application of manure onto the maize crop. Yes, okay, next slide. So in general, we came up with key constraints. Now this was according to feedback we got from farmers, stakeholder organizations, from the government, from the extension staff, from the research department, and other partners on the ground, the other NGOs that we're working with. One of the major concerns was, yes, okay, this all looks fantastic. We've learned that we can grow these crops together with our main crop without too much disturbance to the main crop, which is a big hurdle to overcome. Because immediately when you tell a farmer you're going to grow this crop in your main crop, the first question is, well, this is going to disturb my main crop, and I'm not going to do it. So we've managed to successfully show that you don't get a yield reduction, or if you do, it's less than 10%. The data seems to suggest, as other experience in Zambia has shown us, you get a yield reduction of maybe 5-10% on your main crop, but that's easily compensated by legume productivity if it's done in the right way. So yes, we've seen this can work. Where do we get the seeds? And this is really one of the major constraints, because the focus was on really pushing this idea of integrating green manure crops, multi-purpose green manure crops, or soil multi-purpose crops into the field. Where do we get the seed for this? The other thing is, yes, okay, the jab planter is very good, the direct seeder is very good. How do we access this going forward? Because, they're not accessible. The ripper, it's a slightly different story. It's accessible to everyone, and most of the farmers have been taught about it, but especially when it comes to two-wheel tractors and the implements which are taught by them, the jab planters, these are something which are not readily available in Zambia. And then market for the green manure crops. Again, although we are saying, pigeon pea is a good example, we work a lot with pigeon pea. During the time we were doing our promotion and development of the pigeon pea system, which the project is using, the markets for pigeon pea were very high. There was a shortage in India. World markets were very high. It was around $2,000 a metric ton, and the demand was high. There were buyers in Zambia looking for pigeon pea. As with everything, if you have a set market and overproduction, which was stimulated by the high price, then the price crashes. So there was much less interest in pigeon pea. So these are some of the issues we're facing. So how do we overcome those market issues? Was another concern. Well, cowpea, similar story to pigeon pea, not very stable markets. So farmers were asking, stakeholders were asking, then what do we do to create more incentive for these farmers to integrate these multi-purpose crops? Although there's the element of nutrition, which we haven't really covered here, and I didn't cover in my context for Zambia, which is also very important. We have a very high rate of malnutrition in Zambia, child stunting. In some areas of Zambia, it's actually supposed to be in the top 5 in the world, I think. So on a the national average is around 43% child stunting, malnutrition. So integrating these legumes into cropping systems that are dominant on carbohydrate is also a way to really address nutrition concerns, nutrition issues. And then the other major bottleneck was more information. There was a lot of information stacked into these demonstrations and into the trainings which we gave, and the concern was, how do we access this information when you're not here? So we need materials, we need capacity building in the people who live in our communities, and this was a major concern. And yeah, I mean, for the sustainability of the project, I think this is key. How do we ensure that when the Save and Grow project, which is funded from our various funders, finishes, how do we ensure that this continues and this gets into the Zambian food production basket of options or system? And so briefly, so the solutions to this is educating farmers through stakeholder organizations on the long-term biophysical and economic benefits of the practices. And this is easily said when I'm reading it from a slide, but completely different in real life. There needs to be a concerted effort to get education about these systems really ingrained in the whole education system and service delivery system in Zambia, whether it be through private or non-private institutions. And I think this is really the challenge, has been the challenge for everyone, because we've had ICRAF, we've had various programs promoting legume production, but when the project finishes, the farmers also stop. So where's the sustainability? And this project is quite good. This, in the first year we managed to reach more than 1,000, train, build capacity in more than 1,000 farmers and stakeholders, which is good. But we've got 1.8 million farming households. So how do we really get this ingrained in the system? This is really a question we hope to address by working together with research that informs education and really get it into the national agricultural policy and education framework through colleges, through university, through the research department, so we can really start building something which is going to last rather than just be a project and then finished. Also, how do we support an approach? If I give the example of mechanization, how is the project going to be sustainable in terms of providing mechanization to farmers? Is this the end goal? Reduce drudgery, improve efficiency of the systems, improve productivity, and part of that is sustainable mechanization. How is that going to work when the project pulls out? The project can be there and support buy the machines and support the farmers, and when the project finishes, the machine breaks down and no one wants to finish it, which is the standard setup. When you have these projects, there are good examples of that. So I think the real challenge for this program is how do we support local businesses to come up with a model that's going to work without support. And the only real way to do that is to build awareness on the options that are available and support them in terms of technical know-how. Because we've had various mechanization programs in Zambia, and really the bottleneck has come on maintenance. Repair and maintenance. It's not a strong culture because people don't have a mechanized culture. It's not there yet, so that needs to be supported. And luckily we're working with some partners. We'll cover that on the next one, right? Okay, sorry, I've jumped the gun. Can we go back one, sorry, before we come on to it. So like I said, really promoting or supporting building capacity in research organization, basically government research, to build on the evidence base which already exists, to try and really push these systems forward. Yes, we have some degree of efficiency and some degree of success, but it's not a static thing. Markets change, information changes, so how do we support national research in such a way to build their capacity to move, that they can be dynamic moving forward, really trying to tweak these systems, make them more efficient, and really build a solid evidence base moving forward. And hopefully, if these three things are done properly, that will ensure sustainability on the ground. I also forgot the other stakeholders, so it's not just government, but also the other NGOs are also looking. There's a huge move, as there always has been, but I think it's increasing now, this realization that a dollar spent on agricultural development is the best dollar spent in terms of development in rural Africa. Is a big thing, and there's more money being put onto it through nutrition projects, agricultural productivity projects, sustainability projects, climate smart agriculture projects. There's a lot of interest, but on the ground knowledge doesn't necessarily translate to the interest which is there, or the money which is being put forward by these groups. So it's not just working with government, although that's an extremely important part of it, and working with the education system. It's more also to do with building capacities in other stakeholders that are involved in agricultural development. How am I doing for time, by the way? I've finished the time. My apologies for that. So, so this is, we have currently in Zambia a partner whose mandate it is, they're funded by German government, whose mandate it is to build capacity in farmers and organizations, stakeholders in the agriculture industry towards increasing efficiency in mechanization. So education and mechanization, also farming as business, but maintenance, and really building a service provision, building capacity and service provision for mechanization to happen. Because, like I said, this has really been a bottleneck in the past. And again, coming back to what we're talking about in terms of sustainability, is managing a higher service as a business for mechanical tools. That's really the only way. You can't expect smallholder farmers to buy a two-wheel tractor. If they can't afford 2 bags of fertilizer, they're never going to invest in a two-wheel tractor. But someone operating a two-wheel tractor as a service provision business for farmers becomes a possibility. And the same goes for four-wheel tractors. So this is a very important component, and really will mean the difference between the other approaches, which have generally been to just give people machines, which have generally failed, compared to something which has at least the opportunity to be sustainable in the long run. And I mean, it has to come as prices for labour increase. There will be more demand for mechanisation. This is what's happened all over the world, and it's happening in Africa at the moment, and the trend will just increase. So we have to look at these options moving forward in terms of sustainability. I don't know. You want to take that?
So, Sebastian was mentioning the project, and especially the climate smart crop and mechanization system scaling up has a component on training, on capacity development, and that's framed also in the context of a collaboration between FAO and the European Agricultural Machinery Industries Association, CIMA, because in Zambia, if we can go to the next slide, a partner of the new project will be ACO, and ACO is part of CIMA. So through that collaboration, we'll be working to ensure that the training, and not just for farmers but also for the extension officers, the operators of the mechanization equipment, will be capable of addressing the needs of smallholders in the long term. Of course, it's a one-year project, and so the elements of training that can be covered are relevant, but need also to be translated in a behavioral change, and that's, of course, a challenge. So with that, I would like to thank Sebastian, and I would like to ask if there are any questions here from the floor. Hafiz has a question.
Thank you very much. Excellent presentation. I just want to, I guess, when you were talking about this project, you somehow were hiding the approaches related to the climate smart food production, climate smart system, because you mainly were talking about coping system, about integrated pest management approaches. So, if you
okay, yes.
Are they only just attracting words, expressions, climate smart food, climate smart, but how it's applied in the farmer, in the real life?
Yeah. So
just one second. Hafiz has a question on climate smart agriculture and is asking what it actually means on the ground, climate smart crop system.
So I think from the perspective of the farmers, because these are the people who are receiving this information and are expected to change their behavior according to what we bring to them, it's becoming more and more apparent the changes in climate to everybody. I mean, it's on everyone's lips. Like I said, the last 3 years we've had 2 years of erratic rainfall. One of them was actually called a drought, but I think this year parts of Zambia received lowest rainfall in 70 years. So I mean, the farmers are really feeling it with much more weight than the words we talk about in our meetings. So they're very receptive to ideas, whatever you want to call it, and the way you get it across. I don't think it's so important on the ground when you're talking to farmers. Maybe more important in meetings, planning meetings and such. But the idea is coming across. It's just the way you express it, I think, is different. I don't know if I've answered your question.
Maybe just add, because I think I understand what Hafiz mentioned, and I understand where you're coming from. I think it's really the practices. What practices are there that are actually involved in this system, which therefore provide greater resilience to changes in climate? Okay. I'm thinking things like the ability to choose the variety of a crop which may fit within the calendar because it's changing because of the seasonality, either the temperature driving forward the development, and the other aspect which you mentioned is so important is that you're conserving the soil, you're enriching the soil, which means if there is a dry period or a wet period, it's going to be much more resilient to climate change. And maybe if you don't mind, I'll just ask one question. In terms of the complexity of this situation and having additional crops beyond what's the key staple, but you're enriching the soil, you're conserving it, you're preserving it, you're changing the structure, the biodiversity, you're making it more functionally relevant. How much do the farmers or the government appreciate the importance of that aspect, which doesn't immediately turn into profit? Will do in the long term.
Okay, thank you. So maybe I'll just add to what you said in response to the climate smart question. So yeah, maybe I didn't come across as strongly as maybe I should have, but the main theme is increasing soil organic matter, soil cover, with the effect that you're improving soil structure, which improves infiltration. If you have ground cover, reducing infiltration, reducing water runoff, reducing evaporation, and long-term organic matter carbon leads to increased water holding capacity in the soil, which we've seen a massive impact from these practices over the years in Zambia, and especially the last 2-3 years. It's been very clear for farmers to see. So I think the message is getting across, and also use of manure and any organic matter amendment you can add to the soil within the context, within the farmer context, without too much labor, without too much additional cost, really form the basis of the approach. So to answer your question on how relevant do the farmers see this, and how relevant does the government see this, I think this is, you've touched on a very important point, because it does take time for farmers to see these impacts. And from a government perspective, really government should be, the policymakers should be informed by research. And there isn't much research in Zambia. There's more in the region. There isn't much research in Zambia which pushes this whole idea of recuperating soil, building soil organic matter. And that's something we all have to work on. And if we're to get these approaches mainstreamed in education and in policy making, we really need to put much more effort into lobbying policy to understand the impacts, which is quite easy in the environment of droughts coming around more frequently than they did, and temperature spikes and the other changes we're seeing in the climate. So I would say that's one of the main challenges. Farmers are receptive. They're always looking for new ideas, as long as they don't require too much labor, too much cost, or other compromises in crop yield or whatever. So the approach which we put forward here, the agronomy which is there, has been tested, and for us are the most suited to the Zambian context at the moment. And hopefully this will create a climate where farmers and policymakers can really see this and then say, right, we're going to act on what we see and what the evidence is, and that needs to be generated through agricultural research in Zambia.
Okay. If I'm aware of the time and being mindful of it, there is one more question from the audience that maybe we're able to address, and it's about seeds. Can you provide just a brief comment on that, so that we can close timely this webinar? And the question is on the access of quality seeds, which is a constraint, and what do you think that is needed for Zambia to address this constraint?
Okay. So, as part of the new project, which is upscaling access to the save and grow, elements of the save and grow approach, I think what we need to do is, already some of these crops, they're available. It's not like they're not available at all, but getting them into farmers' hands is the main issue. So, I mean, all of the crops we're talking about have been used in the past in Zambia to a greater or lesser extent, depending on the time and markets for the various crops. The good thing about these crops is they're all open pollinated. So actually, once the farmers have them, traditionally you don't need to keep supplying them. They'll recycle their own seed. There are issues around seed quality when farmers recycle their own seeds, but most of these are pretty stable open pollinated varieties, so it won't need much intervention to keep the crops productive. But really, you know, the new project hopes to work with farmer groups and cooperatives to really create access to input-output markets for some of these crops and the traditional crops, so improving aggregation, storage, you know, post-harvest, even post-harvest processing of some of these crops to make them more profitable for the farmer groups. And a large part of this will be working through these cooperatives, farmer organizations, together with local private service providers. In Zambia we call them agro-dealers, to provide some of these seeds to farmers who want to experiment or want to get their hands on these open pollinated seeds. But really the beauty in it, once the seed is there, it can be recycled by the farmers and shared amongst the farmers. So one of our meetings with one of our stakeholders in Zambia is the Seed Certification Institute, who is responsible on national level with seed laws and seed breeding, and they've said that what they would like to see is to guarantee to have a local production of these open pollinated seeds to reduce the cost and improve the access to farming communities around, while maintaining productivity and overcoming disease issues. So I don't know if that answers your question.
It does. Thank you very much. So thank you, Sebastian. Thank you, everyone, for the attendance. And I think we can close the webinar here. There are useful links here in the last page of Sebastian's presentation that you can access later. Thanks.